What is formula for RMS current? Formula of RMS current?
I naught upon root 2.
I naught upon root 2.
Average current? Average
2
current?
I naught upon pi.
2 I naught upon pi. In AC cycle, we find average for one cycle or half cycle?
Half.
Half. What is power in AC circuit with pure resistance? ERMS into IRMS. ERMS into IRMS. Huh?
Sir.
And if it is AC circuit with inductor, capacitor, resistance, then ERMS, IRMS cos phi. And cos phi is also called as power factor. Today we are going to find total resistance offered by resistor, inductor, capacitor to the flow of AC current. Individually we know resistance R is E by I, reactance XL is omega L 2 pi FL or XC is 2 pi FC. Now we are interested in finding total resistance offered by LCR circuit. Diagram everybody has done? This was the diagram. Inductor, capacitor, resistance. This is alternating source. I am interested in total resistance offered by LCR circuit. So consider LCR circuit connected across alternating source of EMF E, I with the instantaneous current. I said we are interested in finding total resistance offered by LCR circuit to the alternating current. Individual we are knowing, if it is only L, then XL is the resistance, which is 2 pi F. If it is only capacitor, then XC is 1 upon omega C. If it is only resistance, then you know E by I. It does not depend upon frequency. So because all are in series, so I am taking current as reference for all. Same instantaneous current will flow in all. In this case, voltage is leading by 90. Here voltage is lagging by 90. Here they are in phase with each other. Okay, diagram is completed till this. Just check in your book whether you have done this much.
Yes.
Yes, sir.
Now I'm starting derivation. Now I'm removing this diagram if you have done. Consider an AC circuit consisting of inductor L, capacitor C, resistor R connected across alternating source of EMF equals to E0 sin omega t. Let I be the instantaneous current. Please copy to this.
Done, sir.
Let I be the instantaneous current. Therefore, as RLC are in series, hence current across each will be same. Let it be taken as I equals to I0 sin omega t equation 1. Two more line, right? Then I'm rubbing this and coming to the actual picture there.
सर लेट इट बी के बाद क्या लिखा है?
Let it be taken as I equal to I0 sin omega t. Let it be taken as I equal to I0 sin omega t.
यस सर, थैंक यू.
अभी देखो हम लोग ने करंट को रेफरेंस लिया है, ध्यान से देखना. वोल्टेज अक्रॉस इंडक्टर इज लीडिंग द करंट बाय 90, अक्रॉस कैपेसिटर लैगिंग बाय 90, अक्रॉस रेजिस्टर इन फेज विद करंट. ये दोनों के बीच में कितना एंगल है?
180.
180 है, बराबर. अब एकदम सिंपल है डेरिवेशन, थोड़ा बोर्ड पे स्क्रीन पे ध्यान दो. द वोल्टेजेस across R, L, C are given by ER equals to IR, EL equals to IXL and EC equals to IXC. Let I am assuming suppose voltage across inductor is more. Let EL is greater than EC. मालूम नहीं, ऐसे assume किया. Therefore phase difference between EL, since the phase difference between EL and EC is 180 degree and EL we have taken greater. Therefore, resultant EMF across L comma C equals to EL minus EC. Thus, total potential difference or total EMF comma E will be root of ER square plus EL minus EC square. Now this was having EL 90, EC 90. EL बड़ा तो दोनों का रिजल्ट इधर आ जाएगा. फिर ये पाइथागोरस थ्योरम हो रहा है. So resultant of EL minus EC and ER is called total voltage, which is ER square plus EL minus EC square. Therefore, we are writing like this. Okay, clear this much? Hello? Hello?
Sir.
So it's whenever you have a vector, these two vectors are opposite, result is difference, ना? तो EL EC का बीच में एंगल कितना आया 180. तो इसका रिजल्ट क्या आएगा आइदर EL माइनस EC और EC माइनस EL. We told let EL be greater. तो इधर EL माइनस EC आ गया एंड ER. तो ये दोनों वेक्टर का रिजल्ट क्या होएगा ये पाइथागोरस थ्योरम. ओके Hello, is that clear?
Yes, sir.
Yes, sir.
Just copy it in this.
Done, sir.
ER square plus EL square minus EC square. You can say E equals to root of ER square is I R the whole square plus I XL minus I XC the whole square. So we can write this as I square common in bracket R square plus XL minus XC the whole square. in root. That means E is I root of R square plus XL minus X square. E by I equals to root of R square plus XL minus X square. What is voltage upon current called as? Resistance. So by Ohm's law, root of R square plus XL minus X square is resistance offered to the flow of alternating current by LCR circuit. That is called as impedance. So total resistance offered by LCR circuit by alternating current is called as impedance, denoted by Z, which is equals to root of R square plus XL minus X square. Okay, copy it in this, then I am explaining further. E upon Is root of R square plus XL minus XC the whole square. First copy it in this.
Done, sir.
Done.
एक मिनट सर. Done, sir.
Comparing with Ohm's law, the quantity root of R square plus XL minus XC square is the total resistance offered to the flow of alternating current by series LCR circuit. It is called as impedance. It is called as impedance. Its SI unit is ohms. Symbol is omega. Its reciprocal. Its reciprocal is called as admittance. It's called as admittance. ADMITTANCE. Copy it in this. Its reciprocal is called as admittance. Reciprocal of impedance is called as actually admittance.
Done, sir.
Now, this was derived expression for impedance. अगर खाली ऐसे simple पूछा, define impedance, then see what to write. If they ask only define impedance, it is the ratio of RMS EMF to RMS current. E by I मिला ना हम लोग को? That was RMS EMF to RMS current across AC circuit. It is given by Z equals to root of R square plus XL minus XC square. Its SI unit is ohms. Right definition. Done?
Yes, sir.
Right. Phasor diagram for LCR circuit. Phasor diagram for LCR circuit. Phasor diagram is nothing but rotating vector representing quantity with sinusoidal function or quantity varying sinusoidally. This we have done last time. अब एक बार फिर explain कर देता हूँ to draw phasor diagram for LCR. X-axis, Y-axis are taken for reference. Clockwise is negative angle, anti-clockwise is positive angle. Now this time we are taking current as reference point. So current is I naught, which is peak value represented by phasor. Its component on Y will be 0. That means there is nothing along Y axis. EMF across capacitor is lagging by 90 degree. So on negative Y, you can take its EMF EC, which is lagging by 90 degree. And EL is leading by 90 degree. This is EL. This is EC. I am assuming that EL is greater. So result of and ER is in phase with this. So this is ER. This is suppose EL minus EC. So this becomes total EMF E, which is making angle phi with current I. And by here we can see it is nothing but root of ER square plus EL minus EC the whole square. This is called total voltage in the LCR circuit. Draw diagram. Current and resistance voltage are in phase, therefore I have shown it same line. Then EMF is across inductor leads by 90, across capacitor lags by 90. The result is EL minus EC. EL is greater, to now get EL minus EC. And then if you construct this, it will become a parallelogram, a rectangle. Therefore, we are using Pythagoras theorem. Hello? Ayush? आपने किस पे सेंड किया? ईमेल पे किया क्या? कौन से नंबर पे किया है? मैं तो देख रहा, कल किया शायद आपने. मैं तो पूरा सर्च किया, मैंने मिला नहीं. कौन से नंबर से किया आपने? नहीं नहीं, अभी तो पता नहीं यार, अलग अलग नंबर से आप लोग करते हैं ना, तो स्टोर नहीं रहता है ना. चेक करके देखता हूँ. अभी टाइम नहीं है, मैं लेक्चर ले रहा हूँ, चेक करके देखता हूँ. ठीक है, क्योंकि वो एक्चुअली चेकिंग के लिए निकालना था ना, इसलिए वो मिला नहीं आपका, इसलिए देखता हूँ. ठीक है. Hello? Yes, this is your number or Hetvi's number? This the phone on which I am speaking to you. Actually, I have stored Hetvi's number, so I thought it is Hetvi's speaker. Okay, I will just change that name. No, that means I have your paper, na, because no, I have stored as this number as Hetvi's number. So maybe because of that I realized that it is this. Okay. Yes, okay, yes, okay. Bye. Hello? Hello?
Yes, sir.
Yes, completed. Huh?
Sir.
Phasor diagrams for resistor, comma, inductor, comma, capacitor. If we take resistance as reference, so I and E in resistor, they are in same line. That means if E is IR, this is making 0 degree with horizontal. This is also making 0 degree with horizontal. R will also make 0 degree with horizontal. That is, it is in phase with E and I. So if this is 0, 0 equals to 0 plus 0, so R we take as reference. Now E across inductor is I into XL. Now if I is reference, this is leading by 90. So this must be 90, then the left hand side will match with right hand side. So this is taken as XL. So if it is only XL and R, this is called phase angle. This will be impedance root of R square plus XL square, which is combination of R and XL. If it is R and XC, then R is my reference, XC is lagging by 90. This is called impedance and this is angle phi called phase angle. So R and XL has phasor diagram as I have shown in first one. R and XC has phasor diagram as shown in the second. Next see. So XL, XC. Now this is XL, this is XC. That means impedance here will be modulus of XL and XC because we don't know who is larger, who is smaller. Okay, just draw this three diagram. Done.
Last diagram. Done, sir.
Fourth one, Excel, XC, or Excel is greater than XC. And fifth, again, combination of all the three. But suppose XC is greater than Excel, or Excel, XC, Excel is greater, so Excel minus XC will come along positive while this is Z, which is root of R square plus XL minus XC square. This is R, this time XC is greater than XL, so difference will be XC minus XL, and this is impedance, which is root of R square plus XC minus XL. The above phasors are called as impedance triangle. So if they say what is impedance triangle, phasor drawn for R, XL, XC are called as impedance triangle. Now complete these two diagram and write below that hint. Is completed till this?
Yes, sir.
See, any doubt, please ask right now only. Once again, I'm doing brush up of phasor diagrams. Or you have followed full? Hello?
समझा सर.
ओके अभी थोड़ा सा ना कंक्लूजन लिखते हैं, फिर नया टॉपिक पे जा सकता हूं मैं. Conclusions from this phasor diagram of impedance triangle. Conclusion. See, can you see tan phi is XL, difference with XC लिख रहा हूं मैं upon R, because XL बड़ा है तो XL minus XC आएगा और XC बड़ा है तो XC minus XL. Can you see that in this triangle? This is phi, this is XL minus XC, this is Z is R. So tan phi is opposite side upon adjacent side. In this triangle, if this is phi, this is R, this will be XC minus XL. So I've written this phi equals to XL, difference XC upon R. First case. When XL equal to XC, then what will be tan phi? Can you tell me? If XL is equals to XC. Yes. If XL equal to XC, then what is tan phi? Don't take so much time. XL equal to XC, difference 0, 0 upon R is what? 0, no? Hello?
Yes, sir.
So be energetic and respond properly. When XL, XC are same, difference will become 0, 0 upon anything is 0, tan phi 0. So what will be phi?
0.
0. So can I say in AC circuit XL, XC same है, तो XL, XC दोनों भी नहीं है. In AC circuit with pure resistance, when XL, XC becomes 0, then current and EMF are in phase, or we can say phase difference is 0. So sometimes they can ask you for 2 marks. From impedance triangle, obtain the condition for phase angle in circuit with pure inductor, pure capacitor and pure resistance. So when both are equal, we will get circuit is resistive, current and voltage are in phase. Copy first point. चलो क्लियर कर दो ये.
Yes, sir.
Okay, second point. Let us see. If XL is greater than XC, then tan phi will be greater than, tan phi will be positive because XL is greater. tan phi will be positive. If tan phi is positive, therefore this angle phi is also positive. So we can say therefore EMF leads current by phi. Hence the circuit behaves as inductive circuit. Inductive circuit तो leading रहेगा, pure रहेगा तो 90, because it is combination of R and C, so it is not 90. Phi can be 10 degree, 20 degree, 30 degree, 40 degree, and so on. Inductive circuit therefore positive. If XL is less than XC, then tan phi will be negative. Tan phi negative means phi is negative. In that case, we say EMF lags current by phi. And circuit behaves as capacitive circuit. Circuit behaves as capacitive circuit. So 3 points you have to remember. When tan phi is 0, then purely resistive. Tan phi is positive, then inductive is more. Tan phi is negative, then capacitive is more. Copy this 3 point. ये favorite है for MCQ. Completed?
Yes, sir.
Define power factor. Power average power dissipated in LCR circuit is given by P average equals to ERMS into IRMS into cos phi. This cos phi is called as power vector. So we can say cosine of phase angle phi is called as power vector. This power is also called as true power because it is combination of all. Circuit will have everything: coil, capacitor, resistance. So that type of power is also called true power. So average power in AC circuit with LCR is given by P average, ERMS, IRMS cos phi. Cosine of this phase angle phi is called power factor. First definition right, because same thing we can write in three different ways. You can write any one in the exam.
None, sir.
Or the ratio of true power to the apparent power. True power is power in AC circuit with LCR. Apparent power is power in AC circuit with resistance. So ratio of true power to apparent power. Therefore cos phi can be written as true power upon apparent power. That is actually ERMS, IRMS cos phi upon ERMS, IRMS. When you cancel, left out will be cos phi. Or the ratio of resistance to impedance is called as power factor. That is cos phi equal to R upon Z. Right, two more definition. Ratio of R by Z or true power to apparent power or cosine of phase angle is called as power factor. Done?
Yes, sir.
Okay. Right. No. First, in an AC circuit with pure resistance phi is 0. Therefore, cos phi equals to cos 0 equals to 1. Therefore, power factor is unity. In an AC circuit with pure inductor, phi is 90 degree, so cos phi equals to cos 90 equals to 0. Therefore, power factor equals to 0. That is average power for one side. Okay, पहले इतना लिखो, ज़्यादा नहीं, इतना लिखो. In AC circuit with pure resistance, phase angle phi is 0, cos phi equal to cos 0 equals to 1, power factor is unity. So in an AC circuit with pure inductor, phi is 90, cos phi is cos 90 equal to 0, therefore power factor is 0. इसके साथ इनपुट करो प्योर इंडक्टर और प्योर कैपेसिटर दोनों के लिए phi is 90 और प्योर कैपेसिटर phi is 90, cos phi is cos 90, 0, power factor 0. Sure, I'm rubbing this, huh? Can I clear this?
Yes, sir.
So we can say therefore power consumed in an AC circuit with pure inductor or capacitor is always 0. Hence, current flowing is called as wattless current. Current flowing is called as wattless current, or sometimes also called as idle current. Thus, power is dissipated only due to resistance. Make clear now?
Done, sir.
Two more small things I'm doing. Obtain condition for series resonance in LCR circuit. Series resonance in LCR circuit. Resistor R, inductor L, capacitor C connected in series across alternating source is called a series LCR circuit. We are interested in under what condition it is called resonance LCR circuit. So let I be the instantaneous current, E will be the EMF. Okay, just draw the diagram. When resistance R, inductor L, capacitor C are connected in series across alternating source of EMF E0 sin omega t, in series across alternating source, then circuit is called a series LCR circuit. Let I be the instantaneous current. I am interested in under what condition it is called resonance. Done, no? Is completed?
Sir.
Okay. We have to obtain under what condition? It is called as resonance circuit. When resistance, inductor, capacitor are connected in series with alternating source, it is called series LCR circuit. I be the instantaneous current. Total resistance of the circuit called as impedance is given by Z equals to root of R square plus XL difference with XC square. At lower frequencies, when frequency is small, then XC is 1 upon 2 pi FC. XC will be large. So this XL XC ka result will be XC greater. Hence the circuit behaves as capacitive circuit. So at lower frequency, XC is greater than XL. Hence circuit behaves as capacitive circuit. That means effect of capacitor is dominant as compared to inductor. Circuit behaves as capacitive circuit. At higher frequency, XC is ulta of frequency, so it will become less. At higher frequencies, XL greater than XC it is obtained. So I can say hence circuit behaves as inductive circuit. At certain frequency, XL will become XC and circuit behaves as purely resistive circuit, and impedance becomes only resistance. Okay, okay, this much, right? So this all gets cancelled, Z becomes only R. Just two more lines. This condition is called as series resonance. So when I, एक minute देख लो, I का formula is E upon Z. Z becomes only R, so denominator becomes least, current becomes maximum. This condition is called series resonance, where Z becomes R and current becomes maximum. Right further, total resistance of circuit is called as impedance given by Z equals to root of R square plus XL difference with XC square. At lower frequencies, circuit behaves as purely resistive circuit and impedance becomes only resistance. Therefore, Z equals to R and current becomes maximum. That is I equals to E by R. This is condition for series resonance. Condition for series resonance. Completed now?
Yes, sir.
One last small theory for today. Define resonant frequency and derive its expression. Define resonant frequency and derive its expression. The frequency at which inductive reactance becomes same as capacitive reactance is called as resonant frequency. Frequency at which inductive reactance becomes same as capacitive reactance is called as resonant frequency. Let F suffix R be resonant frequency. Therefore, XL equal to XC. At resonance, XL equals to XC. So omega into L is 1 upon omega into C. Omega square is 1 by LC. Omega equals to 1 upon root LC. So 2 pi into resonating frequency is 1 upon root LC. Therefore, FR equals to 1 upon 2 pi root LC. This is the expression for resonant frequency. Please copy. Now only left out is what is parallel resonance and LC oscillation. That will complete our chapter EMI and AC circuit. Very important chapter for entrance, and in fact very easier chapter, even though it appears to be difficult at first instant. Yes, completed.
Yes, sir.
So that's all for today. Please revise and come in the next class, because we will start with numerical in the next lecture. So probably we may be able to complete in on Friday full chapter. The next week we'll start with MCQ of this chapter.